I'm hoping that you thought it was left 1 would be like plus 1 on the inside, and up 1 would be like plus 1 on the outside. Now that's not the greatest answer because like they both are plus 1s, so it's hard to like tell them apart. This one was because you moved it left. This one was because you moved it up. If you just put this for the domain, I would know that you meant the same thing as from negative infinity to infinity. And then the range, that can only be done from a graph, by the way. We have not taught you how to find a range other than from a graph. So if you can't graph it, you can't do the range. So here's the graph. I can see the range, and it's from here up. And so it's the lowest that it ever went to the highest that it ever went. So it's from 1 to infinity. Do I bracket the 1 or not? Do I bracket the 1? What do you think? Is 1 part of the answer? Does it touch 1? Then I bracket the 1. If you touch that spot, it touches 1. All right. So this is just going to ask you for things like, oh, it moved this way and that way. And what is that? That's not a move, though. That negative in the front, what is that? Do you remember that? Reflection. And which part is the vertical stuff? The inside or the outside? Do you guys remember the little snappy saying for that? High, vo. Horizontal on the inside, vertical on the outside. So when they ask, what kind of a reflection is this? It's a vertical reflection because it's part of the outside. This is all on the inside, and so that's all horizontal stuff, like right or left. That's also on the outside. All right. On to number 3. So write the equation for the domain and range. Oh, it's the same basic thing. I guess you probably don't need me for that one. This one, oh my gosh, tons of kids got this wrong on the test. The reason is because they were like, okay, looks like the thing moved, but they didn't know what to write. Here's the thing. You've got to put the f of x in your answer. So there needs to be an f of x in your answer. And now you say to yourself, did that move left or right or up or down? And then I adjust my f of x. So I think it moved to the, well, which one's the original? The pink one or the black one? It's labeled with f of x. So which one's the original? Okay, so whoever's shining on this, can you stop? Thank you. Okay, that f of x right there, that's saying that the pink one is f of x. So this one can't be f of x. It's got to be f of x but changed, all right? So the pink one is the original one, and the other one is the one that's been changed. So you say it's like f of x except it's moved. You tell me, how far has it been moved to the left? Yeah, this pointy thing here is now here, and that is left 1. So then I'd go plus 1. And then this whole black one has been moved down, except how far down did it move? How far down is the black one compared to the pink one? Say it if you know it. 4. It's down 4. So that's how you do it with the f of x. See, a lot of kids forget to put the f of x in there. And then I'd understand why they'd be confused how to write it. Because they're like, well, I don't know what function that is. I don't know if it's an x squared or if it's an absolute value or what it is. If you don't know what the function is, use this f of x. And then you just adjust it by moving it left or right. All right, a few other high spots. We're going to have to go a little faster. This is just an equation where it's been shifted 2 to the right, you know, like that. But it doesn't say what it is. If it doesn't say if it's like a quadratic or if it's a V shape, an absolute value, then you got to use the f of x thing. There, now my equation has been shifted. Again, if they had told me it was a quad like this, see, they told me it was x squared, then I'd use x squared. But it didn't say what it was, so I got to put an F for that kind. What if you had, oh, question.
It says it's a circle for number 5.
Uh-oh, circle. Okay, they did tell me the function. Then I don't use the F. I didn't read it well enough. You're right, it says circle. Okay, so if it's a circle, then just a quick reminder, everybody should probably write this one in. X squared plus y squared equals r squared is your general circle. Now this one's been moved 2 to the right and down 5. So then I change my x and I change my y. And then they must have said something about the radius. Oh yeah, radius is 8, so it's going to be 8 squared. So there's your equation for your circle. You just got to figure out what to put in here. Don't forget to square it. And here. That's moved. The x part is the right and left. The y part is the up and down. One more thought. Kids get this wrong all the time because they're like, can't you trust the y? If stuff's in parentheses, you can't trust it. It does the opposite of what you would think. So when it says down 5, I feel like I should put a -5 here, but I don't. Because it's on the inside, it does the opposite of what you would think. All right. Other topics from this would be just plain old graphing. I honestly don't know what this thing would look like. I mean, if I thought about it more thoroughly, I could be like, oh yeah, it's this function, that's the x to the third function. But it's been stretched and moved in such a weird way, I'm not sure exactly where it would be. So what I do is I make an XY chart. I call it your best friend in graphing. So then I go X, Y, draw the line, and I pick some numbers. Pro tip. Pick numbers that make this part 0. And other than that, pick things that work nicely. So like 0 does work pretty nicely because it makes this whole thing 0, and then 0 to the third is still 0, and then -2 makes -2. There's one of my points. So if you get stuck on a graph, just make a bunch of dots. 0, 2 would be 1 point. Then you go near that. 1 honestly would be a bit of a pain in the butt because half of 1 is a half, and then I got to do 1/2 to the third. So what would you choose instead of 1? 2. Because then half of 2 works out nice because it turns into 1. 1 to the third is still 1. 1 minus 2, -1. So I think you get the idea. You just find a whole bunch of points. Now, should this be this shape except moved? Yeah, but that alone would never be good enough. I mean, my graph was really wonky. It wasn't exactly where it's supposed to be. But is it kind of that shape? Yeah. And it's kind of moved down? Yeah. And it's also got this 1/2 on the inside, which you can't trust. So it seems like it gets half as wide. It actually gets wider than normal. So it's kind of like a big wide one of these that gets shifted down a little bit. So that's kind of where it should be. But exactly where it should be, I would trust your points off the chart. So don't forget to make an XY chart. Anytime there's a graph, make an XY chart. Okay, next page. Now they're just telling me a bunch of words for what they want it to be. Well, they tell me to start with the 1 over x, so that's not that hard. Y equals 1 over x. And then if they say to move it to the right 3, okay, then I can just go -3 because that's on the inside, and that's where the right left goes. Vertically stretched by a factor of 2. Oh, those go in front like this. A lot of kids think that means I times by 2 on the top and the bottom, but if you think about that, the 2's would cancel. Then you wouldn't even be multiplying by 2. If you're really multiplying it by 2, it only goes on the top because 2 is like 2 over 1, isn't it? All right. Okay, so there's a start on that one. And then if I was going to actually graph it, which they want you to make a graph, and asymptotes. This is our first reminder of asymptotes. This is the vertical asymptotes, and the horizontal asymptotes are the kind where you want to try sticking in 1,000. The verticals come from the bottom. We'll have a whole review of that chapter coming up at a later time, but this was just the very first introduction to asymptotes. All right, so this one, I know what to do right away. I see this F in here. That's only if you don't know what the function is. I know what the function is on this one. It tells me at the very beginning, it says the function is x squared of x. So then I can replace this F on all the inside, careful, the inside's the stuff in parentheses, right? With that square root. And now I know what the equation looks like. Do you get how the F stands for like unknown function? And if they tell you the function, then that means you can go stick it in there. All right, I know I'm going kind of fast, but I got to cover 2 chapters a day, or otherwise we'll have to skip whole chapters and they're on the test, right? So I got to go fast. You can always come back and ask me individual questions later. I'm totally okay with that. One thing about order that was really critical is that you remember that the stuff on the inside goes in the opposite of normal order. You know, there's 2 things there. The times by 3 and the subtract 1. Wouldn't times normally go first? Right? Wouldn't times normally go first? So it doesn't go first. That would be the first thing you would do, which is write 1. And then this thing, which seems like it's going to make it 3 times horizontally bigger, but do you get, you can't trust the inside, so it's not 3 times bigger, it's what? Smaller. It's 1/3 as big. All right, so remember that this would be first. I totally get why that is counterintuitive, and it's supposed to be. The stuff on the inside is supposed to go in the opposite order than you would think it would. Then when you're on the outside, it's easier. What should go first, multiply or add? What normally goes first, multiply or add? Multiply. So then it does go first. When you're on the outside like that, you trust it and you do it in the normal order. Okay, so this would be the very first thing you would do. Once you got done on the inside, this would be the first thing you would do because you trust the normal order of things. And this would be the last thing you would do. All right, so there's a moment about order of operations. On to the next page. This is where we take 2 functions and we make the one function eat the other function. Do you remember this deal? I use the example of alligators because they'll eat almost anything. They'll eat license plates and car locks and all kinds of crazy things that they munch on. So this f function ate the g function. Do you remember how to do that? If you do, look at number 13. Everybody make the f function eat the g function. The f is the predator and the g gets eaten. I put an empty spot where the x was so that it can show you what it ate in those parentheses. And there's your new equation. I like to write y, but you get that's the same as f of x, right? So there's f eating g. This one is what we started with, and it ate that one. Yes? Yes, you may. All right. This is another one of those circles I showed you before. Remember, it was x squared plus y squared equals r squared. But remember, this one's been moved, and its radius is known. I can see what the radius is by just counting. And I can tell that it got moved from the original spot over 1 and down 2. So hopefully you can write the equation for that. When you're asked for a domain and range and you're graphing it, then you just do the x values are the domain and the range is the y values. So if I was not sure on this, the first thing I would do is go, oh, f is the unknown function. I'm putting a square root over that because this is the square root function. And then I can make an equation for this. And then I can make an xy chart for it. And domain is about the x and the range is about the y's. And you figure out what's the lowest it goes, what's the highest it goes. Domain is how far left and how far right it goes. I really apologize for I'm basically sprinting here, but this is just the 4th of 7 pages of stuff I need to review to stay on track to have any chance of covering everything. You can always ask me individual questions at the end. All right. Next up, they want us to do whatever that is. Holy cow. Well, just do math one step at a time. Make the f eat the g function. And then we'll stick a negative on the outside of it, and then we'll subtract 2 at the end of it. So you make the f function, which is right here. Eat a g, which is right there. And then it says there's a negative in front and a -2 at the end. That's not that hard. You could do that. And then you make an XY chart. Figure out some points that work well. If you don't know which points to pick, please come up and ask. In this case, you'd start with -4. You always want to start with whatever makes the inside 0. And then you do on either side of that. If you started with -4, you'd do like -3 and -5 would be your next couple points. All right. Now, they gave us this weird function as our f of x. No, g of x, actually. Sorry. That's g of x. Is that a normal function? No. You've probably never seen it before. But if you were supposed to do this to it, you would make an XY chart of your parent points, and you would go through and trust the outside, multiply the, which one's on the outside? The vertical one. Which one's vertical? The Y values. And you'd times all your Y values by 2. What are these X and Y values? They come from here. So one of them is right there, and it was -5, 1. So to do this, I'm going to double, it's on the outside, so I'm going to double the Y. And do I trust this -3 on the inside? No, you don't trust stuff on the inside. So you're going to add 3 to all of the X values. Add 3 here, add 3 here, add 3 here. All right, so then maybe I should get some more of these original points. -3, 1 is another one of my original points from right there. And then this one's at -1, 5. And then that one's at 3, 0. Okay, good. And why am I timesing all of the Y values by 2? Because of that 2 right there, and I trust it, it's on the outside. Why didn't I subtract 3 from the X's? Because I don't trust the stuff on the inside. So I'm changing it to +3 on all of these. And these will give you your new points. 1 times 2 is 2 for the Y, 2 for the Y, 10 for the Y, 0 for the Y. And here we'd have -2 for the X, 0 for the X, 2 for the X, and 6 for the X. All right, that's a reminder of how to do that kind. You start with a list of the parent points and you adjust it from there. Here you would not multiply all your X's by 2, you'd divide them all by 2. Okay, we're on the second to last page. If you can hang in there for another 5 more minutes, you'll have a whole bunch of work time. All right, so what is this? Oh, yeah, you guys are wondering where this is. Okay, this is, remember how I'm doing 2 chapters per day, right? We just finished the first chapter. Now this is the second chapter. So go look in there. It should be called Quadratics A. It also has today's date on it. Find it in Schoology. Take a few notes on it. I was asked, goes up his phone jail. I was asked earlier, will we have to turn these in? I'm going to kind of shake it up. Some days I'm going to say it's your choice. You don't have to do anything. Like, for instance, today, I decided today's, it's you do as much of it as you feel like you need to. Other days I'm going to say, there's a Schoology quiz, you got to do it. Okay? That'll keep it from being just completely loosey-goosey for the whole rest of the semester, where you don't have to do anything, and some kids wouldn't, and then they just bomb the final. And yet have a mix of you need to take responsibility. Many of you are strong enough people to actually practice like you need to for the final. And you'll do whatever you need to. And that, like, you don't have to do these 2 whole worksheets I'm going through with you. But I think it'd be smart to do at least some of it. Depends on the kid then. If you're a perfectionist, you're probably going to do it all. And you probably can't even help yourself. And if you're a super lazy kid, you're going to be like, sweet, I get today off. But it will cost you later if you don't do any practice. You'll do worse on the final. All right, last thoughts on that. Who's going to do well on the final? I can tell you who. Whoever studies for it will. And I don't know if you're gonna study or not, because that's on you. I don't know. If you don't study, expect to do worse than normal, because it's not a normal test. It's 8 tests all at once, and you've forgotten most of this stuff, okay? So if you don't study, you're probably gonna do about a grade lower than normal. Like you could probably just sit in class and kind of just sort of half listen and get 1 grade lower than normal without any more effort. So if you normally get A's, you probably get a B on the final just by sitting here and listening. But if you really want this to matter, like you got an A minus and you're like, dang it, I want the A, you could do it still. And now one last thing that people don't often realize is at the very end of the semester, the teacher has some ability to tweak the grade. We do. And I don't tweak it based on liking a kid. Because there are some kids that are just more naturally likable, they talk more and they're, but I'm really, really careful to not give any grade bumps except for empirical things. Like, if you did really well on your final, that's a reason to consider bumping the kid's grade. They understood everything. If they got an A on the final, like, they got this. Okay, and it shows that they tried at the end. And that's worth something too. Okay, another factor I use is, did they skip tons of homework? If they skip tons of homework, why should I be giving them a break now if they were like lazy all semester? But on the other hand, if they were like I always turn in my homework, that should be worth something. Kid who always shows effort, why shouldn't they get something for that? So there are some elements there that I look at. And for many of you, that's a good thing. You've been doing your homework and you've been trying. And that helps at the end, because if you're really close, and I can tell you have been trying by seeing that your homework is in, and dang, they did pretty well on their final, you're likely to get a break that another kid might not. All right, so do as much of this as what you feel. For today, it's just optional. Do as much of it as you feel like you should. Okay, so what is this even talking about here? Complete the table below. Vertex. What is that? Oh, yeah. That's that vertex form of a quadratic. I'm going to give you an example of one. This one's in vertex form. And surprisingly, it's used to identify the vertex. Do you get the vertex here would be 3, -5? That's one that's in vertex form. Now, you could have made one up, too. That's what they wanted. And, yeah, you could have used, like, H and K, which, for those of you that want to know this kind of stuff, that's typically the letter you'd use, but you don't have to. You can just make up one with numbers. General form is generally ax squared plus bx plus c. And in that case, the a and b and c actually kind of matter a little bit, because, the quadratic formula uses those. And that's where the a, b, and c come from. So in this case, I would use a, b, and c. If you use an example, that's fine. What is general form even good for? I would say the quadratic formula. That's one of the things it's good for. And this number right there means something. Do you remember what it is? The y-intercept. Very good. That's what it's good for. And then how about factored form? Well, of course, you got the factors, but what does that really help you with?
X roots.
Yes, the x-intercepts, or the roots, or the zeros. Do you remember all these words about quadratics, like the vertex? That's that spot. The axis of symmetry, I called it the axis of symmetry, because if the kid just writes 2, I can't give him credit. X equals 2 is the axis of symmetry. The x-intercepts are these dudes. X-intercepts are where y is 0, so it's 1, 0 right there, for example. The y-intercept is where x is 0, and that's this spot. And so the y-intercept in this case looks like it's at 3. So if the y-intercept is where x is 0, it's 0, 3. The equation for this thing in vertex form, well, I'm going to give you a generic vertex form. Do we know the stretch factor? Actually, we can tell it hasn't been stretched. I do that because I went over 1 and up 1. And you can tell I actually only went over 1 and I only went up 1. So it's not stretched. So my A doesn't even exist. It's like a 1. And then here's vertex form generally. And you put the vertex there and there. I'm going to put my h and k in there just as placeholders for now. And that's where you'd put your vertex. Factored form, where could I get the factors? Oh yeah, these guys. So like x minus 1, x minus 3. That's factored form. How about general form? Generally, you just multiply this thing out. Multiply that thing out. Okay. If I had to graph this, I would bust out an XY chart so fast it'd make your head spin. And I would just put in a whole bunch of numbers to be able to graph that thing. But at least I'd know what it's an upside down parabola because it's negative. I'd also know the x-intercepts right there. Like, I'd know a few things. But I'd definitely use an XY chart to try to find some more points. And eventually all your points are going to be like, oh, I wonder what that is. It's obviously an upside down parabola, but I always use an XY chart when I'm graphing. One other really big formula that I haven't mentioned and yet comes up a million times. The axis of symmetry has got a formula for it. We all know that it's x equals, right? But what is the rest of the formula? Remember it? This was all over one of your tests. Negative b over 2a. There you go. If you forgot that, you'd have to multiply this whole thing out to get it. You know, for the a and the b. Like, I can get a easy. It's just sitting right there. But to actually use this little trick to get the axis of symmetry, I have to know a and b. To get to know a and b, I have to have it in general form. So I'd have to multiply it all the way out. Now, could I do it another way? Yep. If I just graph it, the axis of symmetry, if I figure out that it's like going here, well, then the axis of symmetry just runs right down the middle. That'd be pretty easy if you graph it. But the most commonly forgotten formula on the final, that. Make yourself remember it somehow. Tells you the axis of symmetry, and it's the x of the vertex. So, you know, if you want the vertex to get vertex form, that's how you get the x of the vertex. So I usually write the vertex as negative b over 2a, comma, f of negative b over 2a. That's the vertex, and that's the axis of symmetry. And those two together, very, very worth your time to write down because they'll be on the final, and tons of kids forget them. You can look over this right before you took the final. You'd be really happy you did. And I'm on the last page. Stay with me for 2 more minutes and we'll be done. So I can look at this and say it's in a certain form. Can you? Is that factored form? Yes or no? Is that factored form? No. Is it in vertex form? Yes. So if it's in vertex form, what's the vertex? Jackson? Negative 1, negative 12. Good. The axis of symmetry is always the x of that. So what's the axis of symmetry here? Madison, I know? Axis of symmetry is the x of it, so it's negative 1. It's the x of the vertex. What's the a? A is the stretch factor. It's right there. It's just a 3. All right. Could I have not covered all of it? Yeah, I didn't cover everything, but I covered a lot of it. I do want to do one last thing. There's a ton of these little things, and they're asking me for factored form. That just means you just got to factor it. It's not that hard. And get the zeros. Okay, so factoring's not hard. You take a 2 out, and you'd have x squared minus 36, and hopefully you go, oh yeah, I can factor again. X plus 6, x minus 6. Then once you got it factored, the zeros are easy. But what if it's already in this vertex form? Well, then if you need general form, generally multiply it out. And I'm warning you, kids really are terrible at this. You've got to be really careful because they do this. Some people screw that up right off the bat. They think it's x squared plus 1. It's not. It's this. It's got 4 parts. Then you've got to multiply everything that you have by negative 2. And at the very end, The last thing you do is subtract 2 from the constant. So these are harder than you would think to multiply them all the way out. But when you do, you've got general form. All right, and this is just kind of giving you some clues, and I can say, oh, if it's vertical stretch factor 3, I know it starts with a 3. Oh, and it's got a vertex, then I'm going to make it vertex form. And I'm going to slap my vertex right there and right there. Okay, I'm happy to help you with these topics with one-on-one help if you want. So you now have a fair amount of time to look over those 2 chapters, 2 problems, look at the keys. My best advice is do what scares you. Problems that are easy don't really help you. It's like lifting weights. If you walk into the weight room and you lift a 1 pound weight 65 times, doesn't do anything. You got to find something that's hard enough for you. And if it's too hard, you can always look at the key. All right. Thank you for your good attention, and that's all I have for you for the video for today.